Yes, welcome back. And now let's continue our backtracking journey and solve the problem lead code 22 generate parentheses. So the question is like pretty straightforward. You will be given a number n and you have to generate n pairs of parentheses. And the only catch is that every parenthesis should be well formed. So what does well formed mean? Every opening parenthesis should be accompanied by a closing parenthesis. So yeah, this is a valid parenthesis, but this is not a valid parenthesis. Like this is not a valid set mainly because this does not have corresponding closing parenthesis, and so is this, which is not a valid set because this does not have a corresponding opening parenthesis. So just remember, you can have parenthesis inside parenthesis, which has parenthesis, and its neighbor might also be parenthesis, which may be completely enclosed by parenthesis, and it has another parenthesis with also. But yeah, the only catch is that every opening parenthesis must be accompanied by closing appropriate parenthesis. So yeah, see, you see this is actually accompanied by this. This is accompanied by this. Yeah. So that's the only catch. And yeah, this is like a pretty classic backtracking problem. So what we'll do is we'll keep track of two variables, the number of closed parentheses and the number of open parentheses, which we have already added to our call stack. And depending upon the conditions which we will like predefine, we will check if we have to add an extra opening parenthesis on an extra closing parenthesis or we have to directly stop. So yeah, first of all, what does valid parenthesis mean? So every opening must be accompanied by close. So the condition, first condition will be that the number of openings must always be less than the number of closed. Yeah, and yeah, and till when you have to continue till the number of opening parentheses is less than n. Yeah, because when the number of opening parentheses which becomes equal to number of closing parentheses which becomes equal to the total number given n, that means that we have generated n pairs of parentheses. So yeah, yeah, first let's define the backtracking. Yeah, let's fill it when we want. So yeah, now just think about it. So we will begin the backtracking. Yeah, first we will have to declare an answer to all our values. Let's call it answer itself, not ans. So yeah, first we will start from zero. We will have zero close parentheses, zero opening parentheses, and then what you'll have, you will have the answer, and then you will have a temporary variable to keep track of all the possible parentheses which you have generated, and if it is valid, we have to put it inside our answer. So let me, and then we'll return the answer. So yeah, now let's fill our backtracking fast. So what we'll have the number of open parentheses, the number of closed parentheses. Yes, yeah, the number of open parentheses, number of closed parentheses, the answer, and the temporary variable. So yeah, when will we reach our base case? When the number of open parentheses becomes equal to the number of closing parentheses becomes equal to n. That means that we have reached, like we have created a valid parenthesis. So we'll take the parenthesis created, which will be actually inside our temp, and we'll create a copy of that. And yeah, and then we will add it to our answer. And after doing that, obviously we'll return because we don't want to continue further. And if the number of open parentheses, yeah, if it is greater than number of closing parentheses, so what does that mean? You can actually add a closing parenthesis. So take temp, we will add a closing parenthesis. Yeah, after that, we can call our backtracking. Yeah, we'll call our backtracking. Now, since you have added an extra closing parenthesis, increase the number of closed parentheses by one. And after doing all the backtracking, what you have to do? Pop the current closed parenthesis. So next, you might add another opening parenthesis and check, okay, is that valid or not? Yeah. And now, what is the other condition I told? If the number of open parentheses, yeah, you can click on any word and double click it to select the entire word. Yeah, if it is less than n, that means that we can still add another opening parenthesis. So yeah, let's copy this entire part. Yeah, so what you can do, you can actually add an opening parenthesis. Yeah, And since you added an opening parenthesis, the number of opening parentheses should be increased by one. The number of closed parentheses will remain the same. And you will do the backtracking. And after doing the backtracking, you will actually pop out the top of the stack, top of the stack or the temp variable. And yeah, I think this is it. Let's just compile and run once. Yeah, yes, W. Yeah, let's learn English first, and then we'll do coding. And it's answer. I'm so accustomed to writing answer that I wrote ALS. Okay. The only thing we have to do is now we are actually returning an array, but it is actually expecting you to combine the array to a string. So what we'll do? Yeah, we'll actually join it. Yeah, this is just joining it, joining the entire array answer. Yeah, it's working. So yeah, so example, if I put here at the rate sign, what will happen is each element will be joined with at the rate sign in the middle. As you see, each element is actually joined with at the rate sign in the middle. And if I give I don't know big space, what will happen? Yeah, each element will be joined with a very big space in the middle. So we actually don't want anything in the middle. For example, when we are doing what do you call generating all parts of a binary tree, we actually added an arrow. But here there is nothing to add. Yeah, let's just submit it once. And as you see, it worked. And yeah, this is obviously a brute force solution. We are generating we are checking for all the possible lists of parentheses, so it will not be that valid. Yeah, they have also done the same thing. If the open is less than n or if close is less than open. Yeah, it mainly depends upon the internet speed also. And yeah, that's all for it. Thank you for watching and see you.